Here we have a transmission electron microscope. So the source of electron is located on the top, and it's going to travel through the lenses before reaching the sample, which is about at that level. So here we install the very small sample on the sample holder. As we are using electrons, and we see in transmission, the sample has to be extremely thin, typically below 100 nanometers for the electrons to go through. So we place that very small lamina, which is typically 3 millimeters in diameter, into the sample holder before insertion into the microscope. So once the sample is installed in the sample holder, we have to insert it into the microscope. So we put it in the stage, which can then be used to move the sample inside the microscope. And as there is a very strong difference in vacuum, so air pressure here and vacuum, secondary vacuum in the microscope, we have to pump the holder for a couple of minutes. Once the sample is introduced in the microscope, we can see it here. Here we are in scanning TEM, so scanning the beam on the sample. We can then zoom into the sample to identify the different components. Here we have different type of layers. And if we zoom even more in and the sample is well oriented, we will be able to see the atomic columns that constitute the crystal of that sample. Here each dot is one atomic column. At this scale, a hair would be about the size of Louvain. With this microscope, we can look at materials with different type of materials. Metals, semiconductors, polymers, a wide range of materials. And from the information we're going to collect, we can learn about crystallography, size and morphology, or composition, or even how the atoms are bound together and how they are making their interaction with the application. Okay.
Donc là, c'est probablement peut-être un problème qui s'est passé pendant la croissance qui a fait que ça, c'était beaucoup plus poreux que ça. Ça s'est rempli plus quand même.
Ouais.
Et tout ça, c'est des micro-cracks, des nano-défauts de croissance. Hein.
On top of the microscope, we have specific holders which are able to do in situ measurement. Typically, we have one gas holder which injects a very small amount of gas at the surface of the sample, and we can then see also in temperature how the sample is reacting under those conditions. We also have another sample holder, which is a mechanical testing holder, where we can pull on the sample and measure how the deformation is applied to the sample, and measure its mechanical behavior, and also see how it moves during deformation.